How different is the DNA of Northumbria compared to Cornwall, Yorkshire versus East Anglia? Well, in this video we'll uncover the key DNA differences within England and discover what they reveal about your deep ancestry. Now, all English populations ultimately descend from three major ancestral sources: Western hunter-gatherers, early European farmers from around Anatolia, and then steppe ancestry during the Bronze Age, with the latter introduced with the Bell Beaker culture around 2400 BC or so. They also introduced R1b in a significant way into Britain. By the end of the Bronze Age, the people of Britain already closely resembled modern northwestern Europeans. Yet the impact of later migrations and invasions shaped the DNA map of England in a regional and uneven way. Now let's start by looking at the DNA of individual regions. First up is Cornwall, located on the southwest peninsula of England. But what do we know about Cornish DNA? Well, Cornwall consistently emerges as one of the most genetically distinct regions in the country. A landmark 2015 study, published in Nature, demonstrated that Cornish individuals form a tight genetic cluster that is clearly separated from southeastern English populations. The study further showed that the Cornish are genetically closer to people from Devon and Western Wales than they are to those living in the Midlands or the east of England. But while Cornwall shares deep ancestry with its neighbour Devon, don't mistake them for being the same. This 2015 study revealed a striking genetic wall at the River Tamar. In fact, the DNA gap between Cornwall and Devon is actually equal to or greater than the difference between Northern English and Scottish samples. Cornwall shows stronger genetic continuity with ancient Brythonic populations, and less influence from later Anglo-Saxon migrations, while Devon, particularly in the east, displays more genetic affinity with southern and southeastern England. Now, Cornwall's distinctiveness reflects its long history of cultural and linguistic continuity, and its geographical position right in the southwest has also limited large-scale inward migration to some degree at least. And when examined through Y-DNA male haplogroups, Cornwall shows elevated frequencies of lineages associated with Atlantic Celtic populations. R1b L21 appears at particularly high levels, forming the backbone of paternal ancestry and linking Cornwall closely to Ireland, Wales and Western Scotland. And if you look at this table, you can see the full estimated breakdown of Cornish Y-DNA haplogroups. Two other notable branches of R1b are found here, namely R1b DF27, reflecting broader Atlantic Bronze Age networks, and RU106, reflecting more Germanic ancestry. On the maternal side, mitochondrial DNA is dominated by European haplogroups such as H, U5, K, J and T, and this is similar across the whole of England. But what about Cumbria in the northwest? Well, the genetic picture here strongly reflects a Brythonic continuity, but there is also an additional Scandinavian layer. From a historical perspective, Cumbria formed part of the Brythonic-speaking kingdom of Vareged, with the wider region known as the Hen Glaive or the Old North. Genetic data supports this history. This 2015 Nature study identified a distinct Cumbrian cluster positioned genetically between the Welsh, which have a close resemblance to Iron Age Celts, and also Northern English populations, so they sit between the Welsh and Northern English populations, rather than aligning with the genetic profile of southeastern England, with more Germanic-like ancestry increasing as you move more east across England. Now, this genetic makeup in Cumbria is partly due to the mountainous Lake District, restricting large-scale settlement at times down through history. Yet Cumbria also shows clear evidence of Viking influence as well. This reflected Norse settlement along the Irish Sea during the early medieval period. Y-DNA lineages such as I1 and occasionally R1a Z284 are present alongside R1b L21, creating a blended genetic profile that combines ancient British ancestry with Scandinavian inputs. Now, East Anglia presents a very different genetic profile to Cumbria, a region that includes the counties of Norfolk, Suffolk and Cambridgeshire, with parts of Essex sometimes also included. This region consistently shows the highest levels of continental Germanic ancestry in England, and is closer to modern German, Dutch and Danish peoples. An interesting 2022 study in Nature analysed 278 individuals from England from the early medieval period, for instance. And they found that those analysed from eastern England derived up to 76% of their ancestry from the continental North Sea zone, albeit with substantial regional variation. This figure is lower in modern peoples than those samples from the early medieval period, with Anglo-Saxon-like ancestry generally peaking around 30 to 40% in parts of eastern England. Why DNA lineages in East Anglia further support this? If you look at this comparison table between East Anglia and Cornwall, you can see that R1b U106, a lineage strongly associated with Germanic ancestry, appears at elevated frequencies here. Older Brythonic lineages, such as R1b L21, remain present however, indicating that the native population was not eliminated, but rather absorbed into the incoming Anglo-Saxon communities. Scandinavian markers are also found here, like I1 and R1a. Maternal lineages remain broadly European, suggesting that much of the migration was male-biased. Now, if we look at southern and southeastern England, such as Kent and Sussex, they cluster genetically with East Anglia, but typically retain slightly higher levels of pre-Anglo-Saxon ancestry. We know as well that southeastern English populations share some affinity with French and Belgian people, reflecting long-standing cross-channel contact. This was partly explained by a 2022 study from Nature. The authors found that there was a migration of people into southern Britain between 1000 and 875 BC, a people whose DNA was closest to those from ancient France. But how does the Midlands fit into all of this? Well, this region has been a long-running mixing zone linking the south, the north and the Welsh marshes. In historical terms, that fits Mercia, a Midlands core that absorbed and blended Brythonic communities with substantial Anglo-Saxon settlement, then later received additional internal migrations as towns and industry grew. Now, fine-scale genetic studies show that central England forms a relatively cohesive cluster, yet with a subtle east-to-west gradient. The East Midlands lean slightly towards eastern and southeastern English affinity, consistent with stronger North Sea-linked ancestry and later Scandinavian inputs, including areas incorporated into the Danelaw. Why DNA lineages such as R1b U106 and I1 are somewhat more frequent here. The West Midlands, by contrast, shows a mild pull towards the Welsh border counties, reflecting greater continuity with older Brythonic ancestry and slightly higher frequencies of R1b L21. However, these differences are gradual rather than sharply defined. Yet how does Yorkshire and the north of England in general fit into this DNA map of England? Well, Yorkshire and much of northern England again occupy an intermediate genetic position between the west and the east. These areas retain substantial pre-Anglo-Saxon British ancestry, whilst also showing significant Anglo-Saxon and Viking contributions. A 2020 study in Nature Communications identified Scandinavian ancestry in individuals from former Danelaw regions, including parts of Yorkshire. The Y-DNA landscape reflects this layered history. R1b L21, RU106 and I1 are all found here, as well as the Scandinavian associated haplogroup R1a Z284. This highlights Viking Age migration and settlement, particularly along river valleys and coastal areas. But is Northumbrian DNA much different to Yorkshire? Well, the two are pretty much similar overall, but Northumbria tends to lean slightly more towards Anglian associated ancestry. This reflects its role as the core heartland of the early Anglo-Saxon kingdom of Northumbria, and its long ties to northeast England and the Scottish borders. Yorkshire, by contrast, shows a stronger Scandinavian influence, especially in areas that form part of the Danelaw, due to sustained Viking settlement around places like York. So how can we summarise the key DNA differences within England then? Well, the strongest links to Iron Age Britons are found in the west and the southwest of the country, in places like Cornwall and Cumbria. And this speaks to England's primary genetic difference, a clear east-to-west gradient. Anglo-Saxon or Germanic ancestry is highest in the east and gradually diminishes towards the Welsh marshes. Northern and central parts of England occupy a complex middle ground, blending Anglo-Saxon and Scandinavian signals with genetic reservoirs that preserve deeper Brythonic ancestry. Beyond this east-west pattern, England also displays a subtler north-to-south gradient and a rural-to-urban divide. Northern regions exhibit a distinct Scandinavian spike linked to the Viking era, particularly within the former Danelaw. Southern England, by contrast, shows greater affinity with the Iron Age populations from northern France and Belgium, indicating long-standing cross-channel connections. Urban areas like London and York tend to show more genetic diversity as well, while rural areas have remained more genetically stable down through history. So England's genetic landscape is not uniform, but a finely textured mosaic shaped by thousands of years of settlement, migration and regional identity. But why didn't the Roman Empire change English DNA in a major way? Well, to find out, please click here. Thanks for watching, please subscribe and hit the bell, and let me know your thoughts in the comments below, and I'll see you next time.